Let's look at number 81. So we are looking at number 18. If you have number 81, I'm sorry, number 81. So you have a negative binomial distribution with a mean of 6 and a variance of 12. What is the probability that x is less than 3? definition of a negative binomial. Here you want to find the probability of success. And R, you want to find R and P. And you are given the mean and the variance. So the mean is 6 and the variance is 12. X is negative binomial. P of X is 6. Variance of 12. What is the probability that X equals to the probability that X equals to K? Anyway, before we do that, we need, that's what we need first. Probability that X equals to K is what? That's the number of success before the arc failure. The number of failure before the arc success. So if K is the number of failure before the arc success, is this the probability distribution? You can check it, confirm. K is the number of failure before the R success. So there is R success and K failure. K is the number of failure. Or we could write here R minus 1. You can write here K or R minus 1. Now you have E of X. Can someone tell me what is the mean of a negative binomial distribution? Q over P. And what is the variance? Over P squared. So now you want to solve for RQ and P when RQ over P equals to 6 and RQ over P squared equals to 12. So from here, you can see that RQ is equal to 6P. Can you use this to find P? What will be P? 1/2. 1/2? Maggie? You got 1/2? Can we see if majority get 1/2, then the answer is 1/2? Okay, that is how you can reason some of those problems. We have Q. Now you have P, you can have Q, and you can put it into the formula to find P of 0, P of 1, P of 2. Because the question was to find P of X less than 3. So we can see that P equals to 1/2 by replacing it here. Okay, I just want us to, from time to time, go back to what we were doing, do at least one problem instead of just. So last time I introduced the hypergeometric distribution. We will say that a hypergeometric distribution results from an experiment in which a population of n individuals have B of a certain type and G of not that type. So we can say has B success. We shouldn't really call it B success, but and G failure, for example. So a random sample of size n is selected from this population without replacement. Let's do an example. Did we do one example last time? I have an example, maybe on the PowerPoint. Hypergeometric distribution. A population has size n. B has a certain characteristics, or B is of type 1. That's what I use in your note. B is of type 1. B of the members of the population. And n minus B, let's call it, and G equals to n minus B is not of type 1. A random sample of size n is selected. X the number of type B, or type 1, I say type 1. The number of type 1 individual the number of type 1 individual is a hypergeometric random variable. with probability distribution. P of x equals to k is equals to B combination k, G combination n minus k divided by n combination n. So that's I just wrote now what you have on your PowerPoint. Because on the PowerPoint it doesn't look like we did this kind of problem in combinatoric where we have three red balls and 2 blue balls. 3 balls are randomly selected. What is the probability that exactly 2 are red? So I will solve this problem with, I will do this example. And n contains 5 blue balls and 3 green balls. Three balls. Let me put two. Okay, 3 balls are randomly selected. Let me put 2 so that we don't take too much time in doing it. Are randomly selected. Let X be the number of blue balls. Let X be the number of blue balls. X equals to 0, 1, 2. Now we want to make frequency distribution table of X. The first question, what is the probability that X equals to 0? This will be all 2 balls are X equals to 0. All 2 balls are what? If X equals to 0, what does that mean? X is the number of blue balls. Pardon? All the balls are green. So we want to choose 2 green balls out of how many? Out of 3. 3 combination 2. And we are selecting 3 balls. I'm sorry, we are selecting these 2 balls in general out of how many? Out of 8. There are 8 balls, 5 are blue, 3 are green. We select 2. So this is 3. You can use your calculator to find 8 combination 2. That will be 8 times 7 divided by 8 times 7 times 6 divided by 5 factorial. So no, it's 8 times 7 times 6 divided by 2. You can use your calculator to do that. The 8 times 7 times 3. Pardon? 58? 68? I think it will be more than that because you will do 8 times 7 first. 56. Then times 3. 100 and? Okay. Probably. Maggie, can you get it? Using a eight combination 2. No, it was, yeah, it's 56. Pardon? Yeah. I was having 3 in mind. So this is 56 divided by 2. 28. Zero point. So then we will do P of x equals to 1. 1 will be choosing 1 blue ball out of 5. And 1 out of 3 green. And then P of x equals to 5 combination 2 over 28. 5 combination 2 is 5 times 4 over 2. So we will have here P over 28, 15 over 28, 10 over 20. And you can find the mean, the variance, and the standard deviation by using this distribution. For 2, 0, 1, 2, we can use the distribution. But if you have 20, if you have 100 of them, it will be difficult to make a probability distribution like this for 100. So you will have to use the formula. I will just do the mean. Anyway, the mean is, oh, we didn't get, anyway. The mean is B over N. And the variance of X is NB, G, N minus N over N squared, N minus 1. We can get it back to the PowerPoint, but I am just saving time. So having this distribution, you can find the mean here. Let's just check. We could be wrong. The mean here will be 15 over 28. 15 over 28 plus 20 over 28. Do you see what I'm doing? To find the mean here, using this distribution. 15 over 28 plus 20 over 28. 35 over 28. 35 is 5 times 7. 28 is 4 times 7. This is 5 over 4. Now let's use the formula. The formula is NB. N is 2. B is 5. N is 8. And you have 5 over 4. If you are using the formula NB over capital N. But I want you to understand these formulas. That can help you remember the way I remembered. Remember that a binomial distribution xnp, the mean was np, and the variance was npq. So this b over n is the probability of getting a blue ball when you select one ball out of n balls. That is like the probability of success. I will help you to remember the mean of a hypergeometric distribution. For the variance, I will write it as n times b over n times g over n. This is already the npq. So we will add something like that we will call a weight, which is due to the fact that this was not a binomial distribution because there was no replacement. So the trials were not independent. That weight is n minus n over n minus 1. So this is another way to write the variance that you see here. This variance is npq times n minus n over n minus 1. So for our example here, n was 2, b was 5, g was 3, 8 minus 2 is 6, divided by 8 squared times 7. So there is 1, 2 here, 1, 2 here. We change this one into 4 times 4. So this is 9 times 5. You can use your calculator to do it. 16 times 7. So a hypergeometric distribution, I was thinking I will skip it because it's not really a classical distribution that is oftenly used. You think about it when you have a situation in which there are objects to select of two types, like success and failure. So I will continue with, this was 4.5, I think, 4.6. So we have done this example. It happened to be the same as what we were doing. So let's do 4.6. Poisson distribution. So do you prefer when we read the PowerPoint or when I'm writing it instead at fresh? When I write it as fresh, I keep erasing. But writing, right? that your brain is working when you are writing than when you are reading. So that's why you see me sometimes prefer to write than to prepare a PowerPoint and be showing. So the PowerPoint is here. I don't think there's anything wrong there, but we are going to work it together and create our knowledge ourselves. So in a Poisson distribution, you think about, you are given the average number of incidents occurring over a period of time or space. For example, we can say that with every week, there is an average of 3 students that, that's too much. Like 1 student that gets the flu. Let's not call the COVID. For example, so we know the average number of occurrence of incidents. Or you know that in a very busy intersection, there is an average of 2 accidents every month. That is recorded in the police county office, or they have data that provide that. So you know the average number of occurrence of an incident over a given period of time. Or like in biology, you will say that within an area of 5 inches, there is this average number of bacteria. It might not be over a period of time, it can be, that's why I say for space. So lambda is the average number of occurrence. Of an incident. It could be an accident in actuary. It could be sickness in actuary. Average number of claims that somebody can file. Occurrence of an incident over a specific period of time. For space. For space is just to be, for you to know that it's not always time. Then within that, if we say that in a busy intersection, there is an average an accident every day. So it's not like every day there is exactly 1 accident. There could be a day with no accident. There could be a day with 1, 2, 3, and so on. So X is the number of incidents within the period. X is the number of incidents within the period. The incident has T. Jacob is supposed to be reading my handwriting here. Do you think so, Jacob? Because this handwriting is really bad. I'm writing with this pen. No, you have really improved. That's the advantage of college. When Jacob came, I told you that I would have nightmare grading his. I sometimes used to like cancel almost everything. Come and give it back to you. You come back to me. Look at this. This was 2. This is 2. Okay. So the number of incidents over within the same period. For example, if we say the number of accidents within a day, X will be the number of accidents in a day. Then X is a Poisson distribution. Is a Poisson random variable. With probability distribution. E of X equals to K is lambda K, K factorial, e to the minus lambda. We all know what E is, right? The base of the Neperian logarithm, okay? So in statistics, I have to write where E is 2 points so that they know what E is. You can just tap exponential 0. I'm sorry, exponential 1. Okay, so by k is 0, 1, 2. K can go to infinity. And lambda is positive. Is the number of occurrence. It's a positive number. So let's play around with some values. What is P of 0? P of 0 if k equals to 0, what will be the value? What do you think? P of 0. E to the minus lambda. P of 1. It will be lambda e to the minus lambda. And so on. Now let's do an example. Let's say, sometimes when you have a cold, you will want to sneeze, and some people don't like to sneeze. You want to schedule an event, and doctor tells you that a patient with a cold will sneeze in average once every 1 hour. Let's say like that. We can figure that out, right? That when you have a cold, you sneeze in average once, maybe every 30 minutes or once every 1 hour. And you want to know how many tissues should you take? What is the probability that you will sneeze exactly 3 times in 1 hour, for example? So I'm not going to use cold. I just want to say, example, suppose lambda equals to 2. That is, in average, a cold patient will sneeze twice an hour. What is probability that x equals to 0 has the probability that you will not sneeze at all for the 1 hour meeting you are going to get? So E is minus lambda. And this is equal to e to the minus 2, 1 over e squared. What do we have here? Zero 0.4. What will be p of x equals to 1? It will be 2 times p of 0, which is 0.28. You see why I'm getting it from the one we did up here. P of x equals to 2 will be 2 square over 2 p of 0, which is This is lambda x over x factorial. Does it give us the same thing? (0.28). Remember, is lambda x over x factorial e to the minus lambda. So if x equals to 2, this is x. If x equals to 3, will be 2 cubed. Oh, sometimes it doesn't write well. So I was just doing this so that you see how we can work through it. So now, let's discuss the mean. Lambda be a Poisson distribution. And the mean of x is lambda. And the variance of x is also lambda. We started by saying the average number of occurrence is lambda. So we can use that argument to say that we are good to say that the mean is lambda. Now, probability generating function of x. The probability generating function is h of s equals to e of sx, which is sx probability of x. Sometimes I use k, sometimes I use x. But I use x because it's easier to write than k. This is equal to sum of sx lambda x over x factorial e of minus lambda. It is e of minus lambda sum of sx lambda x over x factorial. Let's change x to n if you will understand. Can we check x to n? Or you want us to keep x? Because if it is n, you can see much easily what it is. So this will be, we call this type of variable dummy variable. We can always modify it if we do it consistently. It's almost time, so you are going to finish it. I'm going to put n here, n factorial. Remember that we say that e of x is sum of xn over n factorial from 0 to infinity. You remember this formula for e of x. So what we will say, this is from 0 to infinity. I say x equal to 0, 1, 2 up to infinity. So this will be e to the minus lambda, e to the s lambda. And what is h prime of s? H prime of s here will be, Jacob, what is h prime of s? 1 minute, and then we can go and you complete everything, the proof. What is h prime of s? Look at h of s here. Hmm? Plus, where are you getting the plus from? Hmm? Remember, it's s. S is the variable. That is what I want you to appreciate in this probability. We want to know exactly what is what. The variable is s. Everything else is constant. Can I say it's this one? Right? Okay. Maggie, do you understand why we got that? As the derivative with respect to s. Derivative with respect to s. You do second derivative. Please do second derivative and prove this. Prove, use the formula for the moment generating function for mean and variance. Remember to sanitize your seat before you leave. So if you do s prime of 1, you get the mean. When s equals to 1, you get the mean. Play around with to find the second derivative, which you need to find to compute the variance. Your work was due on Friday. We will just make it Monday. Will that be good? Let's make it Monday. Okay, Daisha, we are good.